Exercise 2, creating standalone payloads with MSF Venom. If the system does not have the latest updates or does not have sufficient security configured, it is prone to be hacked. However, even if these measures are in place, user can still be convinced to execute a malicious application, which could allow an attacker to control the system. Various tools can be used for hacking into a system, such as MSF Venom. It allows you to create custom payloads which can be deployed to the user's system. In this exercise, you will create a standalone payload with MSF Venom and deploy it on the target host for exploitation. Learning outcomes. After completing this exercise, you should be able to switch off the full Windows firewall, turn off the Windows Defender real-time protection, create a payload, share the payload with the victim, use the multi or handler module and exploit the system. Your devices. You will be using the following devices in this lab. Please power this on now. PLAB DC1, PLAB Win1, PLAB Kali. Task 1. Switch off the Windows firewall. You will need to switch off the Windows firewall to perform an attack on PLAB Win10. There are attacking methods that you can use to bypass a firewall running on the target. However, this module, you will switch off the Windows firewall and proceed with the remaining tasks. If you do not shut down the firewall, you cannot connect to the device. Ensure that you have connected to PLAB Win10. The PLAB Win10 desktop is displayed. In the type here to search text box, type the following. From the search results, select the Windows Defender Firewall. The Windows Defender Firewall window is displayed on the Help Protect Your PC with Windows Defender Firewall page. Click Turn Windows Defender Firewall on or off in the left pane. On the Customize setting for each type of network page, select Turn off Windows Defender Firewall, not recommended. For the domain, private, and public network settings, click OK. On the Help Protect Your PC with Windows Defender Firewall page, notice that the Windows Defender Firewall is now turned off for domain, private, and public networks. Close all windows. Task 2. Turn off the Defender real-time protection. You will need to turn off the Windows Defender real-time protection to perform an attack on PLAB Win10. You can use attacking methods to bypass antivirus and anti-malware running on the target. However, for this module, you will turn off the Windows Defender real-time protection and proceed with the remaining tasks. If you do not turn off the Windows Defender real-time protection, it will catch the malware in real time, so when you download the malicious file from plub Kali, it will delete the file immediately. Turn off the Windows Defender real-time protection. Perform the following steps. Ensure you have connected to plub Win 10. The plub Win 10 desktop is displayed. In the system tray on the right, click the up arrow and select Windows Security. The Windows Security window is displayed in the left pane. Click the antivirus. On the right pane, under the Antivirus and Threat Protection Settings section, click the Manage Settings. On the Virus and Threat Protection Settings page in the right pane, click the slider in the right Real-Time Protection section to turn it off. By default, real-time protection is on. The User Account Control dialog box is displayed. Click Yes to continue. Notice that the real-time protection is now set to off. Close the Windows Security windows. Task 3. Create a payload. When you want to create a standalone payload, you can use MSF Venom. To use this tool, you do not need to invoke the Metasploit framework, and it can work directly from the command prompt in Kali Linux. With the MSF Venom command, you can list all available payloads or choose a payload. In this task, you will choose a payload. Connect to Philip Kali in the enter your username text box, type the following. After a successful login, the desktop is displayed. In the menu bar, in the top left, click Terminal Emulator. You can list the existing payload that are available with MSF Venom. To do this, type the following command. Press enter. The output of this command is displayed. Clear the screen by entering the following command. You can select a payload with the -p parameter. To do this, type the following command. Press enter. Notice that the output of the given command, the executed payload with the name payload.x extension is now created. Task 4. Share the payload with the victim. After creating a payload, you need to ensure that it reaches the victim's system. For example, you can share it on a USB, but this may not be possible if you are in different city or country. The easiest method can be to share it on the web, which can be then downloaded by the victim. In this task, you will learn to compromise a host. You need to ensure that the payload file is available to the target system. To do this, you need to start the simple HTTP server. To do this, type the following command. Python simple HTTP server. Press enter. Notice that the simple HTTP server has now started. Connect to Pilogrim 10. The desktop is displayed. In the type here, the search text box, type the following. A new tab open up. In the address bar, type the following URL. Press enter. You are prompted to download payload. That extension. Click save. In the notification bar, click View Downloads. The View Downloads Internet Explorer dialog box is displayed. Right-click the payload.extension file and select Open Containing Folder. Exercise 3, performing online password attack. An online password attack can be performed on various network services such as HTTP or FTP. For example, an attacker might attempt to guess a user's password from a website login. Often server or network devices are not equipped to block an online password attack. Therefore, these attacks can succeed without much difficulty. There are two types of password attack. The first type is dictionary attack, which uses a list of common words. It continues to run through the list until the suitable match is found. On the other hand, a brute force attack attempts to use words based on a given character set, such as with an online password attack. Either one of the methods can be used. In this exercise, you will learn about performing an online password attack. Learning outcome. After completing the exercise, you should be able to use word list, create a user account in FTP, use Hydra to guess usernames and password. After completing this exercise, you should have further knowledge of spraying, plain text, or encrypted. Your device. You will be using the following devices in this lab. Please power this on now. Spraying in a brute force attack. An attacker continued to use random password against a single user account. However, if the organization has a password policy implemented, the user account gets locked out after a specified amount of unsuccessful attempts. For example, the password policy may state that after 5 wrong password attempts, the user account is locked for 30 minutes. Password spraying is a type of brute force method that is considered to be slow and steady. Instead of targeting a single user account with several passwords, the attacker uses a few passwords but several user accounts. In the password spraying method, the attacker will try one password with several user accounts before moving to the next password. They try passwords that are most commonly used, such as 12345 or password. Plain text or encrypted passwords should be controlled by administrators and developers of an application. When plain text or unencrypted passwords are transmitted over an unsecure channel, they are likely to be sniffed. Since the passwords are in plain text, the attacker accesses them without any additional efforts. Similarly, the developers may make the mistake of saving the password in a database in clear text or in encrypted format. If someone gains control of the database, they can access the passwords. Task 1. Create a user account in FTP. You can only crack a password if the user exists. Even for FTP, you need to create user accounts, assign password, and assign the directory that belongs to the user. You can either use the existing user account in Windows and assign them FTP permissions, or you can create new user directly on a FTP server such as FileZilla. In this task, you will create a user account in FTP. Connect to Plog Win 10. You should be on the desktop. Click the File Explorer icon in the taskbar. In the File Explorer window, select Local Disk C in the left pane. In the right pane, right-click, select New, and then select Folder. Name the folder as FTP and press Enter. Double-click FTP to navigate inside it, and then right-click, select New, and then select Folder. Name the new folder Plog, and then press Enter. Close the File Explorer window. In the Type Here search text box, type the following. From the search result, select SAM Control Panel. The SAM Control Panel version 3.2.4 is displayed. Click the Start button for Apache. Similarly, click the Start for MySQL and FileZilla. Notice that the bottom section that the service for Apache, MySQL, and FileZilla have started. Click the admin button for FileZilla. The Connect to Server dialog box is displayed. Keep the default settings and click OK. The FileZilla server has now started. The FileZilla server dialog box is displayed. You will now create a user on the FTP server. Click the single user icon. Which is the fourth icon from the left on the toolbar. The user dialog box is displayed in the user section. Click Add. The Add User Account dialog box is displayed. In the text box, enter Plog and click OK. Back on the user's dialog box, select the password checkbox, and in the text box, next to it, type the following. In the left pane, click the shared folder. In the shared folder select section, click Add. In the Browse for Folder dialog box, expand the local disk C, expand FTP, and then select Plog, click OK. Back on the user's dialog box, click OK. You are back on the FileZilla server dialog box. Task 2. Use word list. A list of words known as a word list is predefined and used to match against the victim's password in the dictionary attack. There are ready-made password lists available on the internet, ranging from a few bytes to multiple gigabytes. However, you can also create your own word list. Some of the tools that are commonly used to do this are WYD password proofing tool, Crunch password cracking and word list generator, CWL password cracking custom word list generator, Mangler keyword-based word list generator for brute forcing. In this task, you will learn about creating a word list. Ensure PLAB Kali device is powered on in the enter your username text box, type the following. In the enter your password text box, type the following, click login or press enter. After a successful login, the desktop is displayed. In the menu bar, click Terminal Emulator. First, let's look at the predefined word lists that are available in Kali Linux. To do this, type the following command. Press enter. Notice several word list files are displayed. However, you will not be using one of these existing word lists. You will create your own new list. Clear the screen by entering the following command. You can use predefined word list, download word list from the internet, or create word list manually. Here you will create a small word list manually. In the command prompt window, type the following command. Leave pad open with the file name plab.txt. Type the following word. Press enter for each except the last one. Press Ctrl S to save. Close the pile of text. To verify that pile of that text has been created, type the following command in the terminal window. Notice that pile of when is created in the root folder. Clear the screen by entering the following command. Kali Linux also contains a tool named tool, which is used to generate word lists. The following command. The command runs successfully. The tool command has created a word list with the words used on the intranet website. To verify the text has been created, type the following command. Notice that the test.txt file has been created. Clear the screen by entering the following command. Let's open the test.txt file and see the words that are stored in it. Type the following command. Test. The test.txt file is now open. It has captured several words from the internet website. Close the file, clear the screen by entering the following command. Task 3. Use Hydra to guess usernames and password. Hydra is a tool that can perform dictionary tasks against several protocols such as HTTP, FTP, SMB, SSH, and so on. Hydra is designed to conduct attacks against authentication services which might be running using a protocol such as HTTP. In this task, you will use Hydra to guess usernames and passwords. Ensure you have power on all the devices listed on the introduction and connect to Pilab Kali. The command prompt window should be open. Now you will use Hydra to perform a dictionary attack using Pilab.txt that you previously created. You have an FTP server running on 192.168.0.3. You will use the pilab.txt file to perform a dictionary attack against the server. To do this, type the following command. Let's see if the Hydra has been able to find the output password of the user's PLab. Notice that the text is green. You have been able to crack the password for this FTP service on the host 192.168.0.3. Clear the screen by entering the following command. Now let's attack the web server running on plab 10. plabin 10, type the following command. The password is cracked using the plab.txt file. Keep the terminal window open for the next exercises. Exercise 4. Performing offline password attack. Users tend to set a easy to remember passwords such as a family member name or their pet's name. To prevent user from using simple password, a password policy is often enforced. Unlike the online password attack, the offline method is performed on a file such as etc shadow in Linux or SAM database in Windows. Attackers use various offline attack techniques to hack the target system. For example, an offline password attack. In this type of attack, the attacker tries to extract the password hashes from database files such as the Security Accounts Manager. SAM is a database file in the Windows where the local user credentials are stored in an encrypted format. In this exercise, you will learn about performing an online attack. Your device, you will be using the following devices in this lab. Please power on now. plab DC1, plab Win10, plab Kali, Task 1, crack Linux password using John the Reaper. Every Linux system has two key files that contains the user and password information. The file is etc password, which contains the general user information such as username, encrypted password, the user ID number, user's group ID number, full name of the user, full home directory, login shell. The etc shadow file stored the user password information in a encrypted form. This file also contains information such as password expiry date, password change required or not, minimum and maximum time between password changes. In this task, you will crack Linux password using the John the Reaper. Ensure you have power on all the devices listed in the introduction and connect to Philip Kali. The terminal window should be open. Firstly, you need to use the unshadow command to combine both etc password and etc shadow files. In this step, you will combine both this file into a single file name path. This needs to be done for John the Reaper to reveal the password. To do this, type the following command: unshadow Notice that the output is generated and command runs successfully. Next, you will use John the Reaper to get the password from the file path. To do this, type the following command: Notice that the password for the root username has been revealed successfully. Task to use ncrack in Kali Linux. Ncrack is another command line tool that can be used for brute forcing the password on various services, such as an FTP service. You can use ncrack with a word list to crack the password for the specific username. You can also provide a list of usernames in a text file and use it along with the password word list file. In this task, you will use ncrack to crack password using the word list. Connect to Philip Kali. Ensure that the terminal window is open. Clear the window with a clear command. You will now use the ncrack tool. Type the following command: ncrack user Philip. The brute force attack start. Notice that the password now is cracked. Close the terminal window. Task 3. Generate rainbow tables. When a user enters a password to log on to the opening system, the password is converted to a hash using an encryption algorithm. Passwords are not stored in plain text format. When the user enters the password, it is converted to a hash, and then the user enters the password. And there's the password. It is converted. If they do not match, then the user is not given access. Once a password is hashed, it cannot be unhashed or reversed. A rainbow table is a database that contains the pre-computed list of plain text passwords. Corresponding hash values, when converted to a hash using specific algorithm, a particular word will always produce the same hash. For example, if you convert password to a hash, it will always generate the following MD5 hash. Rainbow tables can take a long time to create because a single file can contain millions of passwords. However, they can be reused multiple times. You can create your rainbow tables or download them from the internet. In this task, you will generate rainbow tables. Ensure you have power on the device listed in the introduction and connect to Pilog Win 10. Then click Start Expand Chain and click Burns Chain. On the User Account Control dialog box, click Yes. The Chant version 2.94.4 by Mao dialog box is this where click Add Table. The Rainbow Table Properties dialog box is displayed. You will now change some of the values in this dialog box. Change the following values in the hash drop down. Select MD5. In the mainland text box, overwrite the existing value to 5. In the chain count text box, overwrite the existing value to 1000. Keep all other options as the default selection. Click OK. Back to the WinGen dialog box. An MD5 table is now added. Click OK. Select the rainbow table and click Start. Notice that the green If the green check mark appears against the file name, click Exit. You are back on the File Explorer window. Navigate the following. Notice that the MD5 rainbow table is now created in the WinGen folder. Task 4. Close all the File Explorer window. Task 4. Recover Windows hashes using chain and able. Chain and able is a password cracking utility that can help you recover passwords from the various resources such as local and wireless system. It offers various methods to crack a password. These methods are dictionary, brute force, cryptanalysis. In this task, you will recover Windows hashes using Cain and Abel. Ensure you have power on the devices specified in the introduction. Connect to pin 10, then click Start and expand Cain, and then click Cain. When prompt in the user account dialog box, click Yes. The Cain windows is displayed. Click the Cracker tab. From the left pane, select LM and NTLM hashes. Click the Add button on the menu bar. The Add NT hashes form wizard is displayed. Keep the default selection and then click Next. Note that the several user accounts are displayed along with the hashes. In the right pane, right-click the user admin and then select brute force attack and then select the NTLM hashes. Admin. The brute force attack dialog box is displayed. The predefined text box contains a string of characters and numbers. Click the drop down and select the second to the last list from the bottom. The list contains lower and upper cases, letter, number, and special characters, which are all potentially included in a password. Therefore, when brute forcing password, you need to use them so that the correct password can be discovered. From the password length section in the max list box, set the value to 8. Click Start. The password cracking process is initiated. Note the time in the time left field. This indicates the amount of time it could take to crack a password. With the specification you set, it depends on the value defined in the max drop-down. The char set that you choose. The more combination you provide in the char set, the more time it will take to use the combination and crack the password. Click Stop. Exercise 5, explaining physical and other attacks as well as logical attacks. There are physical methods that can be used by attackers. This means gaining physical access to the system, for example, plugging in a malware-infected USB drive into a laptop or stealing the laptop itself. However, most antivirus and anti-malware applications automatically scan USB when you plug it in. Therefore, attackers are coming up with the new methods such as malicious USB cables. In these exercises, you will learn about physical attacks. Learning outcome: after completing the exercises, you should have further knowledge of malicious universal serial bus cable, malicious flash drive, card cloning or skimming, adversarial artificial intelligence, supply chain attacks, cloud-based versus on-premise attacks, cryptographic attacks. Your device. This exercise contains supporting materials for security. Malicious universal serial bus cable. A malicious USB cable can be programmed using a chip that allows the attacker to control it. The user cannot determine whether the cable is malicious or not just by looking at it, which results in them plugging in the cable and giving the attacker control. The attacker can program the malicious USB cable to connect to a mobile device, a cellular hotspot, a wireless network. When the malicious USB cable is plugged in, the attacker can gain control of the mouse and keyboard. Further, malicious USB cable can also be equipped with a GSP tracker. The malicious USB cable works with the following operating system: Windows, Linux, iOS. Malicious flash drive. Even though a large number of users have started to move their data to the cloud for backup purposes, USB flash drive remain a key method for offline backups. There are several types of attacks that can be conducted on flash drives. Repro- reprogram- Reprogrammable microcontroller USB attacks, reprogrammed USB peripherals, software on the USB device, electrical attacks. The most common attack is the software on the USB device. When a malicious USB drive is plugged into a system, the software triggers and infects it. If the attacker wants to destroy a system entirely, it might even trigger a high voltage attack. The USB used to conduct such an attack carries an electronic circuit that can send a high voltage current to the system, eventually burning it. The malware used will change depending on the attacker's intention. A USB can be used to drop or install some of the key malware types such as backdoors, Trojan, keyloggers, worms. Malicious USB are available for attackers to purchase on the black market, meaning that the biggest challenge is not always creating them. It is sometimes harder to get the USB to the users or target. The attackers may simply drop the USB in a parking lot or office to be picked up by a random user. USBs may also be sent as a gift For a convention that the user attend, individuals can also be specifically targeted in this way. Card cloning or skimming. Previously, credit or debit cards needed to be physically stolen or swiped for an attacker to access it. However, as technology has advanced, the new method of card cloning was discovered. Initially, and card and debit credit and debit card has a magnetic strip that stored the card's encrypted information. When a card was swiped, its information could be captured either using software or a hardware device. Once the information was captured and stored in the memory, it has transferred to a new card, creating a copy of the original. This meant that the new card could also be used to make transactions. A card cloner or card skimmer can be placed in a ATM or any system that accepts a debit or credit card. However, the newer debit or credit cards have a chip that cannot be cloned or skimmed. Adversarial artificial intelligence. Artificial intelligence is a method to simulate human intelligence in computer or system. The intent to it the intent is to make the system think like human to achieve a specific goal based on a given problem or data set. For example, a self-driving car or a computer playing chess against a human. Machine learning is a subset AI of AI where AI focuses on the broad idea of making a system execute a task. ML focuses on the required data input that is used to learn a specific pattern. AI uses ML to solve specific problems. Tainted training data for ML. ML requires input data which must be clean and contain no errors. ML also learns through the previous experience. For example, ML may be playing a board game or navigating roads based on its learning experience which comes through the input data known as training data. The training data needs to be clean and accurate for ML to gain experience. However, an attacker can infect the training data or modify it to the intent that the ML gains the wrong learning experience. For example, if the learning experience is based on tainted or corrupt data in the self-driving car, the result could be devastating. For example, not stopping at red light. Security of ML algorithms. The role of algorithms is important in ML. Essentially, it is what the ML runs on. Depending on what you want to achieve with ML, you may have to use a specific algorithm type. For the security of the ML algorithm, the input data must be clean and accurate. With the tainted data, the ML algorithm may end up with the wrong interpretation and wrong learning. Along with this, the attacker may also simply change the logic of the algorithm. For example, if your algorithm uses several if-else statements, making a few changes to this statement harms the algorithm. Supply chain supply chain attacks. If the organization network extends itself into vendors and third parties network, then the attack surface is much larger. Your network may be highly secured, but this may not be the case with the vendors and third-party entities. Research in 2018 by the Ponem- Ponem- Ponemon Institute concluded that 56% of organizations that suffered an attack was due to their third-party entities and vendors. Target is famous example of such attacks. One of the HVAC vendor system was infected with malware which eventually drilled into Target's network. The end result for Target was a major security breach with millions of credit and debit card numbers and data stolen. This also resulted in lawsuit. Often, vendors of an organization such as hardware supplier do not have sufficient security control. Their systems are not checked for security where they connect to the organization's network and may not even have an antivirus or anti-malware installed to catch malware in real time. Therefore, when this system connect to the organization network, they can become the weakest link in this security. Cloud-based versus on-premise attack. Cloud-based and on-premise system security risks are directly proportionate to the security applied to them. Cloud systems have some security advantages, for example, subscription to them often includes a variety of security controls you can use to protect your data. However, the data privacy can be a major concern. You do not always know who is handling the data and whether they are mishandling it at all. With on-premise system, you have a lot more controlling over your data, but the cost of implementing security control is higher. You have to purchase your own software and hardware to protect your network. It is also important to note that the same set of applications that work on the on-premise system can also work in the cloud environment. The functionalities of on-premise applications do not differ when you deploy them in the cloud environment. When you deploy same vulnerability in the cloud environment. Therefore, a vulnerability in a application can be exploited, whether installed in the cloud or on-premise environment. A cloud environment can be proved to attack such as a shared infrastructure failure, malicious insider cookie poisoning in a software as a service environment, malware injection attack, or an end-user attack to steal the user's identity. Cryptographic attacks. A cryptographic attack is conducted on a cryptographic algorithm that has been implemented on a application or servers. However, the developers may not be well versed in the strengths and weaknesses of cryptographic algorithm. The developer may choose a cryptographic algorithm that is easier to implement as many are complex in nature and more difficult to implement. Therefore, developers often take the shortcut of using algorithms that are easy to implement. Let's look at some of the cryptographic attacks. Birthday and collision. A birthday attack is about finding the probability of finding collision in a hashing function in the birthday problem. There is a high probability that is 50% possible than 23 people in a group have birthdays on the same day. Using the birthday attack, an attacker can find a hash function of a text string or a message. Then the attacker can modify or alter the communication between two entities using the collision attack. In the collision attack, you find the probability of one finding a digitally signed message and replace it with another message that contains the same hash. For example, an attacker may find two messages or two string of text that have the same hash output out of two. If a user is expert the first message, the attacker may send its second message with the same hash and cause a collision of the hash function, which refers to the two messages or string of text having the same hash. Downgrade. Most websites would deploy the security socket layer or transport layer security certificate to ensure encryption between the web browser and the web server with the SSL or TLS encryption, a strong encryption from the deployed to safeguard encryption. Data transmission between the two. When conducting a downgraded attack, the attacker enables the backward compatibility with a lower level security in the system and then exploit the system. For example, if the security level of a web browser is set to high, the attacker can lower the security level to minimum and conduct the downgrade attack.